Hello, my name is Sajjad Mohammed, and this is my VBA project. It's the Smart Bridge. So we're currently here on SolidWorks. So we'll go to Tools, Macro, load it up, and get over here. We'll click on our Forms, the Smart Bridge, just over here. We'll click Debug, Run. We'll just wait for it to load up. So this comes preloaded. It has our save folder for the outputs of the files, our workbook upload. So this is where all your sections, your colors, and your materials you can add into the software. Comes preloaded already with the most basic design with the bridge span, width, load class, main beam material, deck type, finish, and safety factor, including a dynamic safety factor. These are some design rules and preferred configurations that you can do for yours. These are the equations that some of them are used, some of the main ones. And this is your design status and your validation of design. So we'll just start off by loading the workbook. It takes a couple of seconds. As we see here, it says materials loaded, finishes loaded, and sections loaded. Already comes preloaded just in case an error pops up. So over here, we have our bridge width. So we can change what width we have. Right, this can be changed in the software, but these are the main priority ones. I don't want to go too far, or I wanted to constrain them. This is your load class, so you can also change this, but this bridge is designed for pedestrians only. It's not meant to go too far and too long. This is your main beam material. This can be changed completely. That was just loaded up through the Excel workbook. This is your deck type. I only have 3 deck types at the moment because I've decided to constrain them because the data would be too long. And also this material finish. The material finish is only based on color. Then costing was added onto it. Then our safety factor. So let's start by showing you the smart decisions and how it works. So let's change this to 60. As you can see here, the design states that it's failed. We need to change the design. And if we just scroll down, move this to the left, it tells us the actions. We need to reduce, span / load all materials, or add larger sections to the workbook. Right. Over here, we'll tell you the preferred sections. This will automatically calculate your options for it. It will try its best. Right. It will even have the beams, right, the depth, the width, the area, right, and the mass. Right. It'll even do the structural results for it, right, and utilization checks, right, and automatic layout output for it for the entire design. So if we change this to 60, it will give us an input error, right? Bridge span must be positive. That is the smart decision of it doing it, right? And over here we can see the create is grayed out. You can't click on it, so you cannot make something wrong. Right? You can only make something right once the software decides and calculates that it's a correct bridge and the correct material and the correct sections, then it will allow you to create it. So if we even change this to ABC, it'll still give out the input error. So we can only give a positive. So we can give it 1 meter, not 6 meters. However, if we, like we said, if we give it 40 meters, right, it's wrong. We need to change these sections. So we'll put this down to 6 meters. And we'll click create. What the software will do is then create all the sections needed in the background. So we'll just let this run. And it's currently doing the DWG drawings needed. For each part. And right here we'll say the Smart Bridge model generation is complete. Output, it created the parts assembly drawings PDF if supported, and CBS bill of materials and text report if supported. So if we just click close on this and actually go over here, right, we'll click on the bridge, and here is our bridge, fully completed with the colors that we chose. So it's dyed it and assembled it completely animated, right. And over here we have our beams and our simple 6-meter bridge, right. And it also creates DWG drawing per part that was used. That includes all of them, right? They are simple rectangular parts, right? And it will give out the length in meters. And even here is the DWG drawing for the full part, just over here. And it will say the dimension schedule for it, right? And the bill of materials that was actually needed to construct this bridge, including the depth, width, and height and span, right? So if we go to this folder over here, this output folder that we set up gives us the thing over here. It will give us a bridge of materials, right? Materials needed. It will give us the estimated maths and the estimated cost, right? That was pre-inputted into it, and the file location for it, right? And the material and the finish needed, right? Don't click save, right? And we get the drawing set out as a PDF completely ready to be sent out, right? And we, over here is the drawings, SolidWorks drawings, SolidWorks parts, and the PDFs required, and the bridge report. If we click on the bridge report over here, just bring it here for us. It tells us everything that was used. The automatic layout, the structural members, the joint rules, the structural equations that we used, right, the costing, right, and the file locations, and also the validated documents. So if we go over here and close this, means I don't want to save any of it, so I just want to close it. And close this, then save this. And I'll close this in a second. Close that. And then we go back to the macro, click on the macro again, debug and run. Go back to the macro. And so we'll just demonstrate along the bridge. So automatically passes because it has the right length. We'll change the bridge width. We'll change this over here. Change the material. Let's say I want aluminium, or with aluminium you can't have it because of the deflection properties. Right? It won't let you do something because of the smart decisions. Right. So over here, tell us increase material strength. Right. We'll always say reduce span or load because of the material needs to be the structure of it needs to be smaller, right? But over here it tells us increase the material strength, right? So what we do, let's say we change this to a very strong high yield steel. We'll change the deck to the timber deck. Change the finish to a clear, right? And also another thing with the deflection, you cannot go lower than 100. It has to be a positive value, right? It has to be greater than 100. So set it to 200, 500, 5,000, and it will fail. That is a calculation. So it makes a smart decision straight for you, right? Just over here. So if we change this to 500, and one of the cool things about this software that I've coded it in is the B. One of the biggest things is this preferred section, right, is the smart decision it makes for you, right? So if we change this down to here, let's just save this and send this to 15, the beam section. So beam section changes, right? It will change per structure that you want, right? So if we change it down to here, it will change, right? It will do the automatic thing for you. So we'll set it to that. We'll have it as 20, and you see the beam section changes, the costing and everything. It's the smart decisions for you. Then over here, we'll click create, and it will make the new part. But if we click validate, it will save as validated. So we'll just load both beforehand. Before we do it, click OK, right? Then we can click create model, but let's say we made a mistake, so we click reset, and it resets it back to the basic defaults, right, that automatically apply. So we'll change this to bridge / footbridge 2026, changes to 20, messed up. Let's make this with a steel, but this is GDPR. We'll go with the matte black finish, bring this diffraction to 500, max spacing to 1200, and bridge the length, we'll put that to 2000 millimeters, right? And guardrail height, we'll drop this down to about 200. And we click validate. It's validated, has the correct sections, the structural load that we can compare to what we actually need for the customer or for our project, right? And the utilization check, so we'll check the bending utilization, the shear, and the deflection and the frequencies, and the overall utilization. Our target is 1, closer to 1 the better, so we could change this. So we'll go, let's go 400. So I'll bring this to, I brought this down to 0.97. It's just to make sure the frequency is not greater than needed, right? Because the frequency, the incorrect frequency for bridges causes it to collapse. So I'll click create, and it'll go off in the background, and I'll start creating it for us. And this is the option of this macro. It's minimal input. You only have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 actual inputs. The 14th one would be the data workbook, which is preloaded. So the menus here, go to our backup, API, Smart Bridge sections, and the Smart Bridge data, and it's just here. That is our finishes. The sections here, finishes, which is just the RGB color, right, and the materials. And I've also put the recommended span applications that's needed for them. So if we close this down and just wait for the software to continue what it's doing. So over here it tells us it's done, and this is the output folder, and the name it's created for us. So I'll just close this, close the macro, and wait for it to load up. And it will make the parts, and we'll change the sections as needed. So we'll close this down. That's the drawings per part, right? And here is our section. So as we change the rail height, change the bridge width, and the bill of materials on the top left hand side, fill for it completely. So we let's say kick this off, and so there is our bridge that we designed. And there is in the map back, and also the fascias and the rails. We made the rails one big unit. We made it one big unit. And here is our beams. It'll tell us what material our beams are meant to be, and how it's fully constructed, how the slats are. But then we did create the GPR for the deck. So and we'll just go back to the just 1 second. Yeah. Just don't save any of them. Just close it all. Right, that's completely closed. We'll go back to the macro. And just let it run. And over here, we now fully actually see how it works. It's the minimal input that's needed for it. It's the automatic validation that we get from it, and the automatic model generation. And one cool feature with it is if we actually go to the output file, we have a new folder of our new design, everything that we need, including the cross members and main beams and the bridge drawings. It validates its design, and it refuses, the main important part that I made it is it refuses an unsafe bridge, an unsafe design, so the bridge doesn't crash, so it doesn't cause a fatality if actually used, right? And a deeper section is selected, cross member count rises and all that. And it makes the smart decisions that's needed before you start actually designing it manually. And it's this cost saving, this time saving that's needed to design a bridge where you can start off with a basic blueprint just from this macro. Thank you.